Hello and welcome back to Chapter 12, Judgment and Reasoning. All right, in this chapter, we are going to be covering judgment. We're going to talk about how we detect covariation. We'll cover the dual process model of judgment and reasoning, some triggers for skilled intuition, confirmation and disconfirmation, logic, and decision making. So we have a lot to get to, so let's get started. All right, so judgment. Judgment is defined as the process through which people draw conclusions from the evidence they encounter. So this is separate from problem solving, which is going to be covered in another chapter. This is how we draw conclusions, right? We're not solving a problem necessarily. We're coming to a conclusion about something. And we're using the evidence that's available to help us to draw that conclusion. So one aspect of judgment is a frequency estimate. That's our assessment of how often various events have occurred in the past, right? So one judgment that we make is, how common is this occurrence, right? How often have I seen something like this? Is this typical? You hear this a lot with weather. People will talk about how unusual it is for it to be raining on this day, or how unusual it is to have such a sunny day, or how unusual this windstorm is, or these kinds of things. They're making a frequency estimate based on their experiences in the world. They're making a judgment about the, prototypicality of what they're experiencing right now based on their knowledge of what's happened in the past, right? And so they're saying, oh, this doesn't happen very often, or it's like this all the time. One thing that I remember we'd always say is that it stops raining on July 5th, and then we get beautiful summer until, I don't know, September 30th or October 15th, something like that. Sort of these judgments, we oftentimes would make judgments like, if you have a really hot summer, then you can expect a really cold winter. And I always wondered what the chicken was and what the egg was in that, kind of relationship, if there is one, between the temperatures in the summer and the winter. Is it a hot summer predicts a cold winter, or is it the cold winter predicts a hot summer, right? Like, what are we basing the frequency on? Are we starting with the summer, or are we starting with the winter, right? What I'm talking about here is that, we oftentimes commit errors in our frequency estimates. We don't always have the direct access that we would need to be able to really accurately understand the frequency of certain events, right? We don't have all of the, temperature information that would help us to know whether today's weather is typical or not typical for this time of the year. We don't have that kind of information. We don't have direct access to how often we ourselves have done certain things. We forget half the time the things that we've done in the past. Or especially if the thing that we've done in the past is something unflattering or embarrassing that we don't want to think about anymore, right? Going back to memory, we don't want to remember things that maybe are embarrassing or for some other reason we want to distance ourselves from those things. We certainly are going to have errors attached to the frequency of behaviors we may or may not have engaged in the past. And that's really, to be expected, right? Because it relies on memory. And so what we oftentimes do is, instead of having an accurate depiction of frequency, we do what's called attribute substitution, where instead of an accurate frequency estimate, we rely on how easily the information was accessed as a proxy for this needed frequency estimate. So if I can think of it really easily, it's probably common. It's probably something that happens so often that that's why I would know about it, right? I've had lots of time to think about it because it happens a lot. So attribute substitution refers to our tendency to rely on something easier to serve as a proxy for the harder thing, which would be to, accurately estimate the frequency of something. So let's talk about two specific attribute substitutions, which are what we call heuristics. Heuristics are efficient strategies that usually, please underline that word, usually lead to a correct answer. We're going to talk in this chapter specifically about availability heuristic and representativeness heuristic. And I want to get started with availability. So heuristics are efficient strategies that usually lead to the correct answer. The availability heuristic tells us that if it's easy to think of, it must be common. Why else would it be so easy to think of if it didn't happen a lot? A lot of this, I think, the availability heuristic logic inside of our unconscious processes that are going on inside of our head, is that, the more times you experience something, the more accessible that information would be to memory, is kind of, I think, that unconscious process that's going on inside of our heads. And so if it's easy to think of, we conclude that it must be common. It must be something that we've experienced a lot. One of the things about the availability heuristic is that it can cause us to be overconfident about what we know. It can make us believe that that what we know is more accurate than it really is. If we can think of it easily, it must be common, and we confidently say that. So this is a little demo I normally do in class. If you'd like to play along, go ahead and grab a piece of paper and a pencil. You can pause me. All right, hopefully you've got a piece of paper and a pencil, and or you don't plan on playing along. So for each of the following questions, you're going to provide a numerical range where you are 90%. The correct answer is going to fall within that range. So if you have no idea about the answer to the question, you're going to want to give a wider range. And if you're really certain about that, what the number would be, try and give a narrower range. I mean, it certainly would not be that interesting if you just said that the range is between 0 and infinity for every question, because certainly every answer is going to fall within that. But are we really testing your knowledge? Probably not. If you're perfectly calibrated, so if you accurately are creating ranges that contain 90% of the answers, then 90% of your answers should be right. So you aren't necessarily going for perfection. You're trying to create numerical ranges that you're 90% sure would contain the correct answer. So let's do one as an example. What was Martin Luther King Jr.'s age at death? So please also, by the way, it's no fun if you look it up. Like, obviously you could Google this. I will tell you the answers. There's no need to Google it. So what you would want to do is set up a range of ages where you are 90% confident his actual age at death would be within that range. So if you're not sure, you're going to give a wider range. Probably, don't say birth and 100, say something narrower than that. I mean, you're probably pretty sure he was an adult when he died, so you're going to probably give a number that's greater than 18 as the bottom, right? So use that kind of logic so that you can try and figure out a range of numbers. So I'll just be making something up, right? So he's maybe between, let's say I don't know. I might say he was somewhere between 18 and 75. I might say something like that. And then I'd be 90% certain he falls within that range. I guess it's possible he could have been 17. I'm guessing it's possible he could have been 80. I don't know. But give a narrower range. Don't give a super wide range if you can narrow it down. Okay, so give a range for Martin Luther King Jr.'s age at death. The next question is, what is the length of the Nile River in miles? So you're going to have some range of numbers that you think the Nile River's length would fall between. Number 3, how many countries belong to OPEC? And you'll notice the question asks OPEC. So there's actually some additional countries that are like part of OPEC, kinda. And I'm not talking about that. That's called like OPEC plus or something. It just says OPEC. So that's all we're looking for. If you don't even know what OPEC is, give a range. OPEC is the oil producing, I don't remember what the acronym actually stands for, but it's the countries that are they're like a conglomeration of big oil producing countries. 4, how many books are there in the Old Testament? 5, what is the diameter of the moon in miles? So that's a line that goes straight through the sphere, right? So what would be the diameter of the moon in miles? 6, what is the weight of an empty Boeing 747 in pounds? Maybe one of your parents or something, or maybe you work for Boeing and you know this answer, but Probably most of you are going to have to go with some kind of range where you're like, I don't know what do I say? So think of numbers that it might be between. 7, in what year was Mozart born? 8, what is the gestation period of an Asian elephant in days? I don't know what the gestation period of a human is in days. 9, what is the air distance from London to Tokyo in miles? And then 10, what is the deepest known point in the ocean in feet? All right, so I wanted to get through them all and give you any characterizations. If you want to really play along, go ahead and pause me and answer each of those questions, providing a range of numbers that you think would contain the correct answer. So you go ahead and pause me if you want. All right, I'll assume that you're back or that you didn't pause me. All right, so let's get to the answers. So Martin Luther King was 39 when he died, when he was killed. The Nile River is 4,132 miles long. There are 12 countries in OPEC. There are 39 books in the Old Testament. The diameter of the moon is 2,158 miles and some odd. A Boeing 747 weighs 390,000 pounds when it's empty. That shocked me. I'm like, seriously, how do planes fly? But anyway, 7, Mozart was born in 1756. An Asian elephant is pregnant for 645 days. So it's almost 2 years. The distance between London and Tokyo is 5,959 miles. And then the deepest known point in the ocean is 35,994 feet. All right, so those are correct answers. So here's the question. We've got 10 items on this list. Did you have ranges that contained at least 9 of them? Right, that would be 90% accuracy. So did the correct answer fall within your range for at least 9 of the questions? If so, then you calibrated your ranges correctly so that you ended up 90% accurate. Probably, you had the opportunity to make a wider range, right? But there are probably cases that you got wrong because the number that you thought was the correct answer was off. Like, for example, I thought Martin Luther King was 42 when he was killed. And so I gave a pretty narrow, the first time I played this little game, I think I gave it like 40 to 45 is what I put. So I was wrong on that one because if I would have just widened it 1 year each way or even 1 year lower, I would have been right. But because I was so confident that I knew how old he was when he died, I made too narrow of a range. And that's what the availability heuristic can do to us. If it's easy to think of, I'm like, oh yeah, he was 42. I don't know why I thought that. I tried to look it up and I'm like, there's nothing here that I'm coming up with that would explain why I thought he was 42. But because it was easy for me to think of, I was really confident that I knew that. So I made a really narrow range on that one. Whereas the diameter of the moon, I got it wrong, but it was like the wrong direction. I made it way too big. So I was just off by thousands of miles and didn't include that one in there. But again, I thought I knew how big the moon was. And so we make ranges a lot of the times because we're overconfident because we think we know things. I really underestimated the weight of a Boeing 747. It was like by a factor of 10 at least that I was off. And so that's what the availability heuristic can do to us. It can make us more confident than we should be. Here's an example of another thing that the availability heuristic can do to us. We oftentimes focus on the wrong things that aren't really the big concern in life, right? The big concerns in life in reality, the things that are killing people the most are heart disease and cancer. If we just judge by how much money is spent trying to combat these causes of death, we see that heart disease is way underfunded. Cancer is pretty decently funded compared to heart disease, but probably not, the correct ratio of cancer funding to actual deaths. But if we looked at the all deaths due to terrorism since 2000 number down here, and then the number of dollars that have been actually spent since 2000, and this graphic is from like 2010, so it's really old. I'm sure these numbers are cumulatively even greater, right? This is annual spending, so it probably doesn't really matter too much that it's old data. But the point I'm trying to make is that a lot of times we worry about the wrong things, and we put a lot of energy into the wrong things because they're really available. It's much more interesting and much more attractive when you hear about terrorism or a mass shooting or something like that and think, oh, we need to do something. And it's a lot less interesting to think about chronic things that ultimately get us, like heart disease or cancer. Extending your life on the basis of something that is probably going to ultimately get us anyway, feels different from putting a lot of energy into trying to prevent something that happens to us, right? That isn't just like inevitable. And so I think because it's easy to think of these big splashy things like an airplane crash or something like that, those are easy to think of. And so we think, oh, something's got to be done. The ones that are harder to think about, we don't really think about protecting ourselves. Part of it is the way that the news covers things. This little graphic shows you this little tiny dot, what's covered in the news versus what actually happens in the world. There's so much stuff happening every single day, right? There's so many things that happen on the planet Earth, or just in the United States, or just in the state of Washington, or just in the Seattle area. Like there's so, I mean, you could go down to pretty small and still say there's too much stuff happening here for us to all pay attention to it, right? For it to be available to all of us. And so we get attracted by the things that are easy to think of, and we sort of let the rest of it all just sort of fall by the wayside. All right, I'm going to stop here, and then in the next video, we'll pick up with the other attribute substitution, which is representativeness heuristic.